Hi everyone, and thanks for joining me in this session where we'll take a look at how AWS is empowering more personas to generate value from machine learning. My name's Rick Fraser and I'm an Analytics Solutions Architect with AWS based in Melbourne. I'd like to start this session by taking a look at where we are in the enormous growth cycle of artificial intelligence and machine learning and some of the use cases that are driving its mainstream adoption in the modern enterprise. We'll then talk about some common challenges associated with implementing machine learning and what AWS are doing to make it easier for more customers to leverage this technology at scale. After that, I'll demonstrate how you can use the AWS platform to build accurate ML models without any coding or any data science experience. So machine learning, which is a branch of artificial intelligence, has gone from being an aspirational technology to mainstream very quickly. For a long time, ML was limited to a few major tech companies and hardcore academic researchers, but things started to change very quickly when cloud computing entered the mainstream. The rise of cloud computing has made compute power and data more readily available, and we now see machine learning making an impact across all industries. It's moving from the periphery of businesses to becoming a core part of how they operate. According to Gartner, 70% of enterprises will shift from piloting to operationalizing their AI architectures by 2025. And in a Deloitte survey of AI adopters, 75% of people saw AI transforming their industry in the next 3 years. With this kind of momentum, ML is becoming an absolute necessity for businesses who want to remain competitive throughout the next waves of disruption. So what are some examples of this machine learning driven transformation? And where exactly are we seeing it? We're seeing ML transform businesses of all types and sizes. Government organisations, like Transport for New South Wales, are using machine learning to help forecast demand across their entire network so they can better plan their workforce and asset utilisation and also improve customer satisfaction as a result of that intelligent planning. Their train controllers benefit from data-driven recommendations on how to mitigate and efficiently recover from service interruptions so that passengers can ride in comfort. Mecca Brands, a beauty and skincare retailer, they have always had a strong focus on their highly personalised in-store experience, but they wanted to extend that experience into their online platform. Using machine learning, they're now generating more than 10 million tailored product recommendations every week across their entire catalogue. This means that they can show their customers products that are relevant to their life stage, their journey, and also their purchase history. And this online personalisation has resulted in an increase in email revenue of 76%. And Domino's, who you'd probably recognise as a global pizza business, they're using machine learning extensively to optimise for customer experience. Domino's realised that the sooner they could get a pizza to their customers, the more satisfied they were with their meal. So they launched an initiative to see how they could use predictive technologies to help reduce pizza making and delivery times. They implemented a machine learning enabled ordering system so that when customers begin ordering a pizza online, machine learning models are predicting the likelihood that the order will be completed. And if their models predict that the order will be carried out, they'll actually start making the pizza ahead of time so that you can get it faster. In 2019, this enabled an Australian Domino's store to average delivery times from order to doorstep of under 5 minutes across an entire week. This simply would not be possible without machine learning. Now, these are just a few examples of customers who are successfully leveraging ML to optimize business processes and improve customer interactions, and there are many more. But a lot of businesses have trouble scaling machine learning across their organisation. And to understand why that is, we need to take a closer look at the ML value creation process. Currently, the ML development lifecycle looks something like this. It usually begins with a business case and a set of requirements that can drive value for an organisation. So for example, we might want to predict the inventory required over the next few months so that we can satisfy customer demand based on seasonal trends and other inputs. Or we might want to use sensor data to predict the likelihood of equipment failure so that maintenance teams can be allocated more intelligently and expensive repair scenarios can be minimized. And there's many other examples like sales conversion, churn reduction, or fraud detection. But usually what we find is that whilst the business teams have a long list of use cases that they'd like to explore, the data engineering and data science teams that they'll rely upon to deliver those initiatives, they have an equally long backlog that they need to work through. So the teams sit with each other, they rank each of their use cases by expected value and complexity, and then they need to decide what the priorities are, given that they're resource constrained and they can't do all of the use cases at once. Once they've decided upon the priorities, the data engineers and data scientists need to gather all of the required data from different sources. They need to merge them together, clean and standardize the outputs, and then start the process of feature engineering for the particular problem that they're trying to solve. Then, the data science teams need to build models that are appropriate for the problem type. They have to iterate on different features, different models, and tune different hyperparameters on top of those models to optimize their outputs so that they get the most accurate predictions. And once that's complete, they give their most accurate model to their ML ops team so they can deploy it into production and ultimately make it accessible back to the business teams who requested it. And what we hear from our customers is that this process can be very iterative, it takes a lot of time, and it takes a lot of expertise. Often it takes weeks or months, and as a result of that, they can only execute on a subset of the initiatives that they came up with in the beginning. They can't test all of their ideas, meaning that the process is difficult to scale. So how can you scale this process of ML creation to increase the number of use cases delivered? Well, if we think of the ML model development process as a funnel, where we have business teams generating a lot of creative ideas at the top, things like inventory forecasting or predictive maintenance, and then collaborating with ML teams with the objective of delivering value at the bottom, what we typically see is that there is quite a significant imbalance in resourcing as we move from the top to the bottom. And it's not uncommon to see a ratio of business analyst to data scientist of around 20:1. So with these resource constraints in the ML team, we can only test so many ideas at once. And in order to scale ML value creation, we need to optimize the throughput of this model development process, or we need to widen the funnel so that we can test more hypotheses and generate more value. And you could argue that there's 3 different ways that you could achieve this. First, you can help increase the productivity of your ML team. And this is the core objective of Amazon Sagemaker Studio. Amazon Sagemaker Studio provides a unified platform where you can perform all of the ML development steps that we saw earlier in a single pane of glass. And our customers are telling us that this is helping them improve their ML team's productivity by up to 90%. So if you're not familiar with Sagemaker, then I'd highly recommend tuning into some of today's data science sessions or reaching out to AWS so that you can learn more about it. The second option is to scale the ML team that you already have, to increase its size so that you can meet the demands coming from your business teams. This sounds like a pretty nice solution, but it actually comes with another set of problems. The demand for AI and ML skills over the past 4 years has grown astronomically. Based on the LinkedIn Emerging Jobs report from 2020, the demand for AI ML talent has been growing at a compound rate of 74%. That's 74% growth in demand for these skill sets year on year, which is also twice as fast as any other emerging job role out there. And given how new this field is, it's no huge surprise to us that there's just not enough talent out there to meet all of the market's demand. So what else can we do? The third approach is tapping into the business teams that we already have and helping them to build and use their own ML models. If we could democratize the development of machine learning models with a completely no-code experience, our business teams who already have the rich domain expertise could quickly tap into the power of ML and generate more value on their own. This approach would allow for more ideas to be tested without having to scale up the ML team. But let's see why that's been challenging in the past. What we hear from our customers is that Analysts are very familiar with spreadsheet technology and business intelligence tools. They're excellent at performing complex analysis by diving into data, applying their domain expertise, and then getting insights back to the business. But analytics and machine learning usually require lots of different data sets, and they're often spread out across multiple systems. And combining these data sets from various locations and transforming them in an automated and repeatable fashion has required extensive input from data engineers. Depending on the type of data platform they have, joining and cleansing datasets in preparation for analytics and machine learning would require some form of programming experience, usually in languages like SQL, Python, or even Spark. And even if the data engineering team have cleansed and prepared all of their data for ML, the field of machine learning has required an end-to-end understanding of that entire ML workflow that we walked through earlier. Once the required data is available and cleansed, analysts would then need to know what type of feature engineering is required for their particular use case, and they'd need to know what model is best suited to the given problem type, and how to optimize the performance of that model. All of these skills take a substantial amount of time to build, and as with data engineering, building models would also require you to be able to read and write code, most likely in a few different languages. So if we're to successfully democratize ML innovation, we need to empower our business analysts with toolsets that enable them to cleanse and transform their data and then build ML models on top of it without having any experience in coding or data science. And today, I'd like to show you an example of how that can be done on the AWS platform using two services that offer a completely no-code experience. The first of those services is AWS Glue Data Brew. AWS Glue Data Brew is a visual data preparation tool that makes it easy for data analysts to clean and normalize their data and prepare it for analytics and machine learning. Analysts can use this tool to automate data quality processes like filtering for anomalies, and they can also draw upon over 250 built-in connectors to perform common transforms like joining and aggregating, or even ML-related transforms like one-hot encoding. DataBrew automatically creates a lineage map for all transformation steps that have been taken against your datasets, and it saves these steps as a recipe that can be executed on an ongoing basis as new source data arrives on your platform. After your data is ready, you can immediately use it for analytics and machine learning projects. The second tool we'll look at today is named Amazon Sagemaker Canvas, and it was recently announced at re:Invent in 2021. Sagemaker Canvas expands access to machine learning by providing business analysts with a point-and-click interface that allows them to generate accurate ML predictions on their own without requiring any machine learning experience or having to write a single line of code. With Canvas, analysts can connect to a variety of data sources like spreadsheets, their S3 data lake, or even their data warehouse in Redshift, and then build and train models using AutoML technology. And this means that analysts don't need to choose a model type or tune its hyperparameters. Sagemaker Canvas will build multiple models and identify and then select the most accurate model based on your dataset. Once built, you can use the model to generate either single or bulk predictions directly in the visual interface. Sagemaker Canvas also integrates directly with Sagemaker Studio so that you can share your models with your data science team and gain their feedback, or even have them deploy it for use in further applications. For both of these services, you only pay for what you use and there's no upfront commitment. For this demonstration, I'll be performing the role of a business analyst in the bank team who's working with the marketing team. The marketing team are planning to run a campaign that promotes their term deposit facility, but they'd like to be more targeted in selecting the customers that they contact via phone because it's a time-consuming and an expensive process. They know from previous campaigns that they have better success when targeting customers under the age of 70, but they've asked if I can help them improve their accuracy using other techniques beyond basic age filtering. In order to build the machine learning model, I'll first upload the historical data to Amazon S3. S3 is a highly scalable and highly durable cloud storage service, and it integrates nicely with other services in the AWS Analytics and Machine Learning ecosystem. I'll then use AWS Glue Data Brew to cleanse the data in preparation for machine learning before outputting again back to S3. Once my data is cleansed, I'll use Amazon Sagemaker Canvas to build my machine learning model that will help me narrow down the target customer list for the marketing team. The dataset provided by the marketing team gives some customer demographics like age, marital status, and education, a few macroeconomic indicators like the Consumer Confidence Index and the 3-month Euribor rate. It gives me some customer interaction data like the duration of the customer's last contact with the marketing team. And importantly, it tells me whether or not the customers have subscribed to a term deposit facility. This makes the dataset great for training a machine learning model. I've uploaded the historical data to a dedicated location in Amazon S3, and I can now begin the cleansing process in AWS Glue Data Brew. To get started, I'll create a new Data Brew project. I'll use Marketing Optimization as the project name, and I'll select a new dataset. I can see the name of my dedicated S3 location here, so I'll click on that and select my historical campaign CSV file. I want to make sure that Data Brew has a representative sample dataset, so I'll instruct it to use random rows for sampling, and I'll increase the sample size to 2,500 records. I need to provide Data Brew with a role that gives it permission to read my data, so I'll select a role that I generated earlier, and we can now proceed with creating the project. The project creation can take a minute or two, so I'll speed up the playback for this section. Now that my project has been created, I'm presented with a point and click interface that shows me a sample of my historical campaign data. I can scroll through the 2,500 records in grid format, and I can change to a schema view to see more aggregated information about my data. Using the data quality field, I can quickly notice that only 90% of the records in my age field are valid, leaving 3% as missing records that I'll need to remove. The value distribution chart indicates that I have a maximum age of 94, but I know that the marketing team wants to focus on customers under 70, so I can also filter out these records using a built-in transform. All of the other data quality indicators are in a good state, but I'd like to rename the field named Y, which tells me if a customer has subscribed to a term deposit, to outcome. This is the field that I'll be trying to predict later with my machine learning model, so I want it to have an intuitive name. Back in the grid view, I'll now start applying filters to the customer age field. To begin with, I need to remove the records that have a missing age. I can do this by using the built-in missing transform and selecting Remove Missing Rows. By applying this step, I'm adding it to a list of transforms that form the Data Brew recipe. I also need to remove customers with an age above 70, and I can do this using the filter transform and applying a less than condition. I've just noticed that my marital field has two versions of married, one with a capital M. I want my machine learning model to treat these values as equal, so I'll use the format transform to set all values to lowercase. There are a number of other built-in transforms available to help me do things like remove duplicate records, aggregate or summarize my data, map existing values to new values, and even perform one-hot encoding. For now, I'm pretty happy with how my data looks, so I'll go ahead and create my job. I'll provide Data Brew with a job name, an S3 location for my output, and I'll use the same role as earlier to give Data Brew permission to write to my S3 location. The steps inside my recipe have been saved, and I can edit or remove any of these steps in future iterations of my job. At the top of the screen, I can see that my job is running, and I can inspect the progress using the Job Details button. The job will take over just a minute to complete, so I'll speed up the playback for this section. Now that my job is complete, I can click on the Output field and validate that my cleansed data has been written back to S3. With my output confirmed, I'm now ready to start building my machine learning model using Amazon Sagemaker Canvas. When I open Sagemaker Canvas, I land on the models page that lists any machine learning models that I've created in the past. I want to create a new machine learning model, so I'll click on the New Models button. Once I provide a name for my model, Sagemaker Canvas will ask me for a dataset to use so that it can train the model. I want to use the dataset that was just cleansed in Databrew, so I'll navigate to that dataset and click on Import. Before long, my dataset has been imported, and I can now move forward with the model build. Once the data has been selected, Canvas asks me to tally which column I want to predict. I want to predict the outcome field that I renamed earlier, so I'll locate that in the drop-down box. I can see a value distribution of the outcome field, which tells me that about 89% of customers in my training dataset didn't subscribe to a term deposit, and roughly 11% did. Next, I need to choose a model type. Sagemaker is recommending that I use a 2-category model, which is sometimes called binary classification, but there are other types available, like a 3+ category model type, also known as multi-class classification, numeric model type, which is regression, and if our dataset was time series in nature, we could even do a time series forecast. Since we're just trying to determine if a customer will or will not subscribe to a term deposit, I'll take the 2-category model recommendation. When it comes to building my model, I have 2 options, a standard build and a quick build. The quick build chooses speed of model build over accuracy, and the standard build prioritizes accuracy. I'm going to choose a quick build and kick off the process. This model build will take around 2 minutes, but I've already prepared a standard build model that we can take a look at. To open the previously built model, I click on the models page and navigate to the model that is marked as ready. When I open the model, Canvas immediately tells me that the accuracy of the model is about 89.5%. It gives me information on feature importance, which tells me that duration and age have the greatest impact in determining whether or not a customer will subscribe to the term deposit. And on the right, I can visualize the relationship between feature and outcome for all of the features. But then I can also see scoring. So Canvas has actually put aside about 20% of the sample data off to the side, and it's run these records through the model to assess its performance. The reason these records are kept off to the side is because we don't want to pass the model records that it's already seen during training. I can very quickly see which ones it got correct and incorrect, and I can also get other insights that tell me that if the model predicts a customer won't sign up for a deposit, the chances that it's correct are close to 98%. And of the customers who did not sign up for a term deposit, the model identified just over 90% of them. But if I want to see more detailed information, I can click on the advanced metrics, where I'm provided with additional performance metrics like the model's F1 score and accuracy, its precision and recall, and the AUC. And I'm also given a diagram, which is known as a confusion matrix, which is a nice way of visualizing the model performance. What it tells me is that of the roughly 8,000 customers in the scoring dataset, just over 800 customers converted, which is the true positives plus the false negatives. It also tells me that the model predicted just under 1,400 customers would convert, which are the true positives plus the false positives. And in doing so, it correctly identified 695 of the roughly 800 customers, which equates to a coverage of about 82.9%. What this means for the marketing team is that rather than making over 8,000 phone calls to identify roughly 800 customers, which would be a 10% hit rate, they could use my model to reduce the call list from 8,000 to 1,400 customers, and they'd still reach 82% or nearly 700 of the 800 potential customers. In order to use this model to make predictions for the marketing team, I can click on the prediction tab, where I have the option to run either batch or single predictions. The batch prediction tab is where I can upload new data from the marketing team to help them narrow down their call list. For illustrative purposes, I'll use some existing data to run the predictions. Whilst I wait for the batch to complete, I can also make single predictions. In the Single Predictions tab, Sagemaker Canvas has pre-populated a single record using average values from my training dataset. Based on the average values, my model is predicting that the customer will not sign up to the term deposit. But I can edit these values to see, for example, what would happen if the customer was aged 45 and had a last call duration of 600 seconds or 10 minutes. By clicking Update, I'm running inference on a single record, and my model tells me that based on this input, it predicts that the customer would sign up. To retrieve my batch of predictions, I can go back into the Batch Prediction tab, click on View, and I can then download the results to share back with the marketing team. And finally, if I'd like to get some help from my data science team, I can share my model with them by clicking on the Share button, adding a note, and generating a link that they can use to inspect my model directly in Sagemaker Studio. As a data scientist receiving the model link, I'd be taken directly to the model overview screen on Sagemaker Studio. From here, I can open a data exploration notebook that shows me things like value distributions, data samples, whether or not there are any duplicates in my records, and also cross-column statistics that show correlation between different features. By opening the Model Details page, I'm provided with model explainability information like feature importance, accuracy metrics, details on hyperparameters, and I can also assess model performance and other model artifacts. In the demonstration that we just went through, we were able to both cleanse our data and build a machine learning model that solves a business challenge using toolsets that require no data science or no coding experience. In this example, building a simple binary classification model meant that we could potentially improve the marketing team's call accuracy by a factor of 5, and we could do that based on just 10 minutes of working with really easy to use toolsets. We're living in a period where the types of questions we need to ask of our data are ever increasing, and the opportunities to reimagine old processes or invent entirely new experiences are virtually unlimited. Machine learning technology is entering the mainstream, and it's relevant for businesses across all industries. In order to scale the value that we generate from machine learning, we cannot rely exclusively on small teams of data scientists and ML engineers. We need to supplement these teams by enabling our business teams, who have rich domain expertise, to apply machine learning to their data. And as we just saw in the demonstration, we can do that by enabling them to self-service across a larger portion of the data value chain using low-code and no-code toolsets. If you want to start leveraging the benefits of ML, but you don't have a background in coding or data science, then I highly encourage you to begin your journey of ML innovation today using no-code toolsets like AWS Glue Data Brew, which lets you prepare data for ML using a visual interface, and Amazon SageMaker Canvas, where line of business professionals can generate their own ML predictions, all without writing a single line of code. Scan the QR codes on screen to learn more about Glue Data Brew and SageMaker Canvas. And if you're new to the AWS platform, then I encourage you to get engaged with our training and certification content. AWS Skill Builder is our online learning centre that makes it easy for anyone, from beginners to experienced professionals, to build AWS cloud skills. We offer hundreds of free digital courses that can help you and your team ramp up on AWS. The content is offered in up to 16 different languages, and it allows you to create flexible learning plans that are aligned to a specific domain or job role. We also invite you to join the AWS Certified community, which brings together AWS certified practitioners and builders in an exclusive online community. You can participate in discussion forums and in learning and networking opportunities, and you can even take on challenges from the AWS team to earn rewards and recognition. Scan the QR codes to get started with cloud training and certification. Thanks for joining me in this session today. I really hope you found it insightful, and I can't wait to see the value that you'll unlock by enabling more personas to use machine learning at scale. Have an awesome summit, and as always, please don't forget to complete the survey. Thanks for watching.